Happy World Cup, everyone. It's about to start in a couple of hours, just saying. But anyway, here is a lesson. We're going to just quickly go through a review of basic kind of trigonometry. Remember, SOHCAHTOA, I guess, is an important thing to make sure that we remember. Sine is opposite over hypotenuse. Cos is adjacent over hypotenuse. And tan is opposite over adjacent. So if we remember that, then hopefully we'll be good to go. So we're going to look at finding sides and angles. Basically, I'm just going to do 3 examples and see how we go. This is revision basically from year 9. Should be able to manage this stuff. But let's go from here. So let's say we have a right angle triangle. And we have an angle in here of 30 degrees. I know that the hypotenuse is 15 meters, and I want to find x. Now, step one, question is, which ratio? Well, in this case, we've got the opposite side to the angle, and we've got the hypotenuse. Now, opposite of hypotenuse would mean SOH, so we're going to use sine. So, sine 30 is what we're going to use for this step. Step 2, write the expression. So I need to write the expression out for this triangle. So it's going to be sine 30, sine of 30 degrees is equal to x over 15. And then, of course, step 3 is solve. So, well, if I want to get x on its own for this one, I'm going to multiply both sides by 15. So we're going to get 15 times sine 30 degrees is equal to x. So if I turn it around and I find what that is, now in this case it's going to be 7.5. Making sure if units are involved, 7.5 meters. So that's an example of finding the side. All right, let's do another one. Number 2. Let's say we've got a triangle that looks something like this. And I have an angle in here of 55 degrees. And I want to know what the hypotenuse is, y. And I have this side down here, which is 10 centimeters. All right, so we've got to think, well, what is this? Well, this is the hypotenuse here, and this is the adjacent side to the 55. Now, which ratio involves adjacent and hypotenuse? Well, it's cos. So we're going to write the expression. That's if we decide that it's cos. Step 2 is write the expression. So cosine cos 55 degrees is equal to adjacent 10 over hypotenuse, which is y. Now, this is slightly different from the earlier question. We've got the y in the denominator here, and we want to get that on its own. Now, what we're actually doing is multiplying by y and then dividing by cos 55. But practically speaking, it kind of ends up being a bit of a switch of the y and the cos 55. So we get y is equal to 10 over cos 55. Now we find what that is. Y is equal to, now bear with me as I get my calculator and make sure that we can actually work this out. We've got 10 divided by cos 55. Now I get this, 17.43447. That's to 5 decimal places. Now, of course, that's too many, but it's always a good idea to write with many decimal places before we round. So let's say I then want to I can make sure I can look at that and say, okay, it's going to be 17.4 centimeters in this case to 1 decimal place. So there's a case where we're finding the hypotenuse, or the thing in the denominator. Whereas the first example we did, the unknown was in the numerator. So it just depends on the way we approach it. So there's no hard and fast rule, you just have to take it one thing and question at a time. Okay, let's do one more. Question 3. Let's say we have a triangle. It's a right angle triangle. It's a right angle in there. We have it going along, and the angle here is 70 degrees. No, I lie. I take that back. We don't know it's 70 degrees. We're just going to call that theta. We want to find theta, and the question says find theta. Now, I happen to know that this side over here is 35 meters, and this side here is 17 meters. So the question is, how do I find that? Well, the same process. So we think, okay, well, what sides are involved? This is the hypotenuse, but the hypotenuse is not part of this. This is opposite to the angle, and this angle, this side here, is adjacent. Now, which of the three ratios has opposite and adjacent? Well, the answer is, you're telling me, tan. Tan theta is equal to opposite over adjacent, so 35 over 17. Now, if I have a situation like this for sine, cos, or tan, we don't remember that tan, sine, and cos are operators. We have to undo it. And the way we undo it is by using tan, or sine, or cos inverse, we call it. This thing with a little -1. Tan inverse of 35 over 17. Now, on the calculator, if you have a sharp, it'd be second function, tan, and then you type the fraction. If it's on the Casio, I think it would be shift, and then second function, shift tan, and then 35 over 17. So if I find this, which hopefully I'll be able to, we can do tan inverse of 35 over 17. Close the bracket. And I get 64.0934 ... Just keeps going. So I think for angles, it's probably okay to go the nearest degree or minute, but if we needed to convert, we could do that. But make sure that we say nearest degree. Now, if you can do all those three, then that's basically it. So the next little exercise, we've got exercise 6.4. Be able to work on that and work your way through. Now, if you really feel keen, you can start on exercise 6.5 as well, which is revision from year 10 and year 9. All right, enjoy, have a great day. I'll see you next week.